In this project, we'll make a maze solver using the A-star search algorithm.
For our maze search, we decided to use an A-star algorithm. It's a very simple equation which finds the shortest path using f equals g plus h. So the g parameter is the cost from starting at the starting node and going to the current node that you're at. And since we set all the weights equal to 1, it's just how many nodes has been traversed. Now the h parameter is an approximation heuristic, which is the estimated cost from the current node that we're at to the goal node. To get this value, we use a modified Euclidean distance, which takes the x and y components of the goal node and subtracts them from the x and y components of the current node, squares those values and adds them together.
During our final project, we utilized the Turtle graphics system in Python, and with it, we were able to create a graphical representation of our maze. Utilizing an A-star Python algorithm from GitHub, we implemented it into our code. This algorithm, however, used ones and zeros to construct its maze, and the output would then print to the command window. Our turtle code used an array with x's instead of zeros and ones, so we had to then come up with a solution to convert the maze information to one that would be recognized in our code for turtle. This was done through combining the matrices, where the end output would be the result of the optimal path using our A-star search pattern in our maze. Code for our A-star search algorithm initialized both an open and closed list. Then the start node was added to the open list, ensuring f was set equal to 0. The main loop begins and runs until the goal is reached. This loop consists of getting the current node and moving it to the closed list. If the current node is the goal, the path is reversed. In the main loop, children are generated, and the children of the current node are equal to adjacent nodes for each child in the children. If child happens to be on the closed list, continue to the beginning of the for loop. The f, g, and h values are then calculated. If child is already in open list, and if the child.g value is higher than the open list nodes, continue to the beginning of the for loop. Last but not least, the child is added to the open list.
So this is our input maze. As you can see, it's an array of strings. X's are the walls, and the spaces are where we can move. P is the player, and right now it's at the start point, and E is the end point that we're trying to reach. And in this part of the code, we're converting this array of strings into an array of zeros and ones, and passing that to the A-star algorithm to find the path to the end. Now, when we run it, it should show the maze getting populated row by row. And then you will see the player move and show the path to the endpoint. Now, if you go back to the code, we can just edit this here to change the way the maze looks. So we add an opening here. And then the robot finds a new path to the endpoint.